Good morning, one and all. My name is V. Avjit Kumar. My roll number is 249518662. I'm studying in CSC, AI and ML, that is Computer Science and Engineering, the specification of Artificial Intelligence and Machine Learning, 4th semester, Institute of Aeronautical Engineering. In this tech talk of the subject of computer networks, the topic I'm going to speak about is opportunistic network routing algorithm based on overlapping communities and communication willingness. So let's go to discuss about the topic. So first of all, let's go through the contents. In the first place, I'm going to introduce the topic of opportunistic networks. I'm going to explain about understanding intermittent connectivity challenges. Next, we'll go through the key challenges in opportunistic network routing. I'm going to explain about network topology and resource constraints. And after that, I'm going to explain about communities and overlapping community structure. Then I'm going to explain about exploiting social structures and overlapping communities. Next, we'll go to the slide of communication willingness in routing decisions. We'll be discuss about evaluating node cooperation and resource availability. And after that, I'm going to explain about algorithm design or design algorithm design framework. I'm going to explain about routing processes and delivery benefits. Routing process and delivery benefits. Next, I'm going to go to the slide of performance benefits and routing outcomes. There I'm going to explain about benefits of performance. And after that, we'll go through routing process visualization. I'm going to explain about message flow example. And after that, I'm going to conclude the topic with key contributions and practical impact included. Now let's discuss about introduction to opportunistic networks. Opportunistic networks represent a paradigm shift in mobile communications characterized by intermittent connectivity where nodes communicate only when physical proximity permits. Traditional routing protocols, which assume stable end-to-end paths, fundamentally fall in these environments. Instead, successful routing strategies must exploit social behavior patterns and mobility of the characteristics of network participants. Community-based routing approaches significantly improve delivery efficiency by recognizing that the nodes interact more frequently within established social groups. This is the introduction to opportunistic networks. Now let's discuss about key challenges in opportunistic network routing. Dynamic topology. No fixed network structure exists. Connections form and break up unpredictably. That is the main problem of this uncertain world. Network partitions. Frequent disconnections create isolated network segments. That is also an outcome of this unpredictable world's uncertainty. Delivery delays. Messages experience significant latency awaiting forwarding opportunities. Resource constraints. Limited buffer capacity and serves restrict energy reserves restrict forwarding capabilities. Replication overhead. Excessive message copying wastes scarce network resources. These fundamental constraints motivate the development of intelligent, socially aware routing strategies that can effectively navigate intermittent connectivity whilst preserving limited resources. Now let's go through communities and overlapping community structure. Now let's first of all understand the social network communities. In opportunistic networks throughout the world, nodes naturally cluster into communities based on interaction frequency and social relationships because that is a part of their nature. Community detection algorithms identify these strongly connected groups. Crucially, overlapping communities allow individual nodes to simultaneously belong to multiple groups. For example, a person, a person he might be a part of both their workplace and hobby communities. These overlapping nodes serve as vital connectors between different network regions, acting as bridges that facilitate intercommunity message transfer and significantly enhance overall network reachability. Hence, this is all about communities and overlapping community structure. Now let's go through communication willingness in routing decisions. Now, what is communication willingness? A metric representing a node's readiness and capacity to forward data on behalf of other network participants. It quantifies cooperation potential. Key influencing factors. These communication willingness have three main key influencing factors. First of all, remaining energy. Higher battery levels increase willingness. Buffer availability. Adequate storage space enables message custody. User cooperation. Owners' altruism and sharing preferences. Now, let's go through strategic routing benefits. Preferentially selecting high willingness forwarders ensures efficient forwarding. This reduces packet drops through resource awareness and optimizes overall network resource utilization. Hence, this is all about communication willingness in routing decisions. Now let's discuss about algorithm design. Decision framework. Routing algorithm employs a local adaptive decision-making process when nodes encounter one another. First of all, nodes meet, then they compare communities, then they check willingness, and then they forward if met. The following decision, the forwarding decision is made by evaluating two critical conditions in parallel, two or more critical conditions, depending upon the scenario. Here we have to discuss about forwarding criteria. A message is transferred to the encountered node if either the node shares more communities with the designation the destination that than the current carrier, or the or if the node exhibits uh, higher communication willingness to relay the message onwards. Here we have four algorithm advantages. First of all, no global network knowledge is required. Decisions made using local information only by the local information. This framework adapts dynamically to network conditions and it balances social and resource considerations. Hence, this is all about the decision framework. Now let's go through performance benefits and routing outcomes. Here, mainly we have to discuss about three performance benefits. First of all, delivery improvement. 35% of delivery improvement occurs. Higher message delivery ratio compared to a basic epidemic routing. It's called delivery improvement, and 48% of overhead reduction occurs. It's decreased network overhead versus flooding based approaches, and 42% of energy savings occur. That is lower energy consumption through selective forwarding. And coming to the routing outcomes, scalability. It maintains the performance in large-scale network deployments with hundreds of nodes. Social awareness. Effectively leverages It effectively leverages community structures and behavioral patterns for intelligent routing. Resource protection. It prevents resource exhaustion through willingness-based forwarding constraints. Hence, this is all about performance benefits and routing outcomes. Now let's go through routing process visualization. Let's go through a message flow example. Consider that a message traveling from source S to destination D through intermediary nodes. The message initially resides with S, which belongs to the committee AB. The committee AB. Upon encountering node X with communities B, C, D, the algorithm recognizes that X shares community D with the destination. If X also demonstrates adequate communication willingness, the message is forwarded. Node X then carries the message until meeting another with even stronger destination affinity or higher willingness. Hence, this is the message flow example. Now let's go through the next slide. Now let's finally conclude the topic with key contributions and the practical impact. Hence, the opportunistic network routing algorithm based on overlapping communities and communication willingness provides an efficient solution for data forwarding in intermittently connected networks. Here, four key contributions we have to discuss about them. It exploits social structures through overlapping community detection. It incorporates node cooperation levels via communication willingness metrics. It balances delivery performance with resource consumption. It operates efficiently without global network knowledge. The practical impact is that this approach proves highly suitable for modern opportunistic and delay-tolerant network environments, including disaster recovery scenarios, vehicle network, and mobile social networks where traditional routing fails. By intelligently combining social awareness with resource consideration, the algorithm achieves superior performance whilst remaining practically implementable. And now I would sincerely thank the respected professor to give for giving me this wonderful opportunity to speak upon this wonderful topic. Thank you.